In the history of aerospace, few combat aircraft have been introduced with a marketing campaign that relied less on the roar of afterburners and more on the scent of a limited edition fragrance. Yet this is precisely the surreal trajectory of the Sukhoi Su-75 Checkmate, a machine unveiled at the MAX 2021 airshow not merely as a light tactical fighter, but as a geopolitical disruptor scented with glass, genuine leather, and metals. This scent, presumably designed to mask the aroma of industrial desperation and hydraulic fluid, heralded Russia's most ambitious attempt to overturn the dominance of the American F-35 Lightning II by offering a single-engine, stealth-capable platform that promises fifth-generation supremacy for the price of a well-equipped business jet. The Su-75 represents a radical departure from the prevailing doctrine of the Sukhoi Design Bureau, which for decades has staked its reputation on the massive twin-engine flanker family of heavy air superiority fighters, shifting instead to a monolithic gamble on downsizing, cost reduction, and modularity that is as much a product of economic necessity as it is of aerodynamic innovation. This aircraft marks a historic return to single-engine design philosophy, breaking with more than 3 decades of Russian aerospace tradition that had relied exclusively on twin-engine configurations since the MiG-23 Flogger era. The aircraft's physical configuration is a study in the art of compromise, balancing the rigorous geometric demands of low observability with the aerodynamic necessities of supermaneuverability, featuring a distinctive blended wing-body architecture that abandons the traditional horizontal stabilizers of the flanker lineage in favor of a V-tail rudder-vader empennage that significantly reduces the radar cross-section from the side aspect while reducing drag and structural weight. The most visually arresting and engineering-intensive feature of this design is the Diverterless Supersonic Inlet, a chin-mounted air intake that wraps around the lower nose and eliminates the heavy, complex mechanical splitter plates found on earlier generations of supersonic fighters. This inlet utilizes a precisely computed, 3-dimensional compression bump to separate the turbulent boundary layer of air clinging to the fuselage from the clean air entering the engine, a solution that saves hundreds of kilograms of weight and eliminates a major source of radar reflection. Though the initial angular design seen in 2021 has seemingly evolved by 2024 into a straighter, more simplified inlet, lipped to correct airflow instability issues identified during wind tunnel testing. Patents and technical documents published in recent years indicate that the initial design underwent significant modifications, including changes to the fuselage sides, strakes, and air intakes to further reduce radar signature, while the overall lifting surface area of the airframe appears to have been increased for improved performance. Inside this airframe lies the heart of the machine, a propulsion system that currently exists in a state of transitional flux. While the initial prototypes are almost certainly powered by an engine derived from the Su-35's, a capable but older generation power plant, the operational relevance of the Su-75 hinges entirely on the successful integration of a clean-sheet 5th-generation engine designed to deliver approximately 16 to 17 tons of thrust. This new power plant is engineered to be 30% lighter in specific weight than its predecessor, while delivering up to 18% greater efficiency. This new engine is critical for achieving the aircraft's claimed top speed ranging from Mach 1.8 to potentially Mach 2, and its ability to supercruise, meaning sustained supersonic flight without the fuel-guzzling use of afterburners, while its serrated chevron nozzle is essential for reducing the infrared signature that would otherwise make the single-engine jet a bright beacon for enemy heat-seeking missiles. The propulsion system also incorporates 3-dimensional thrust vectoring, a signature Russian technology that allows the nozzle to deflect exhaust in both pitch and yaw, granting the Su-75 the ability to perform post-stall maneuvers that can theoretically allow it to turn inside the radius of Western competitors in a close-range dogfight, provided the pilot or the computer can manage the rapid bleed of energy that accompanies such theatrics. Moving from the engine to the cockpit, the Su-75 attempts to leapfrog the cluttered interfaces of the past with a glass office philosophy centered around a massive panoramic display that spans the instrument panel, mimicking the interface logic of the F-35 and allowing for customizable windows for sensor fusion, navigation, and weapon status. The cockpit layout is reportedly identical to the Su-57, featuring two large multifunctional displays and a wide-angle head-up display providing excellent situational awareness. This interface is the primary point of interaction for the Matryoshka automated logistics and support system, an onboard artificial intelligence suite named after the famous nesting dolls that is marketed as a digital co-pilot capable of performing real-time predictive maintenance diagnostics and even executing tactical flight maneuvers to reduce pilot workload. The Matryoshka system allegedly utilizes predictive analytics to monitor the health of every subsystem, theoretically allowing ground crews to replace components before they fail based on vibration and thermal data rather than rigid schedules, a capability that would drastically reduce operating costs if the Russian aerospace industry can overcome the crushing sanctions that limit access to the high-end processors required to run such complex algorithms. The concept of a virtual co-pilot also extends to manned-unmanned teaming operations, where the pilot could potentially coordinate with autonomous wingman drones in real-time combat scenarios. The Avionics suite itself is anchored by a multifunctional integrated radio-electronic system, which includes a nose-mounted active electronically scanned array radar capable of tracking 30 aerial targets simultaneously and engaging 6, while functioning efficiently in heavy electronic countermeasures environments. The radar system is being specifically developed as a low-cost alternative optimized for the export market, sharing components and architecture with the proven Su-57 system to reduce development costs. Complementing this active sensor is an infrared search and track turret positioned forward of the canopy that allows the Checkmate to passively detect and stalk stealth targets by their heat signatures without emitting radar energy that would betray its own position. The electronic infrastructure is built on an open architecture philosophy, meaning that export customers could potentially integrate their own national avionics, software, and weapon systems, similar to what Israel has done with their F-35 fleet. However, the production of these advanced avionics faces a severe bottleneck due to the restriction on Western microelectronics, forcing manufacturers to rely on domestic chips that lag generations behind in processing power and thermal efficiency, potentially compromising the fidelity of the sensor fusion that defines a true fifth-generation fighter. To truly understand what the Su-75 represents, we must compare it to its primary competitor, the American F-35 Lightning II. In terms of physical dimensions, the two aircraft are remarkably similar, with the Checkmate measuring roughly 17.5 meters in length with an 11.8-meter wingspan, only slightly larger than the American jet. Both feature single-engine configurations, internal weapons bays, and advanced stealth shaping, yet the philosophical approaches differ dramatically. The F-35 has been in service for years, with nearly 800 units produced and delivered to over a dozen allied nations, complete with an established pilot training infrastructure and proven combat systems. The Su-75, by contrast, remains in the prototype stage with no flying examples and relies heavily on theoretical specifications. The cost differential is where Russia hopes to make its mark, offering the Checkmate at an estimated $30 to $35 million compared to the F-35's price tag of approximately $80 million. This price advantage could prove decisive for nations with growing air forces but limited defense budgets, countries that have been effectively priced out of Western fifth-generation options. Now I want to hear from you. Do you think the Su-75 Checkmate will be a revolution in affordable fifth-generation fighters, or will it remain just another paper tiger that never truly takes flight? Drop your thoughts in the comments below. And if you're enjoying this deep dive into cutting-edge military aviation, Smash that like button and subscribe to the channel so you don't miss our next video. The weaponization of the Su-75 is defined by its need to maintain a stealth profile, necessitating the carriage of ordnance within internal bays buried deep in the fuselage. The aircraft features 5 internal hardpoints in a large main ventral bay capable of housing heavy air-to-surface munitions and 2 smaller side bays located forward of the main landing gear, specifically sized for short-range air-to-air missiles. When stealth is not required, the aircraft can utilize 6 external hardpoints for additional ordnance, dramatically increasing its payload capacity for permissive environments. The primary offensive punch for standoff strikes is a hybrid guided missile and glide bomb that combines a warhead with a rocket motor to achieve a range of up to 120 kilometers, allowing the Su-75 to engage ground targets from outside the envelope of medium-range air defense systems. For engaging hardened targets or conducting deep strikes, the aircraft accommodates a cruise missile, which has been redesigned with a low observable cross-section and folding wings to fit efficiently within the rectangular constraints of the weapon bay, offering a strike range of nearly 300 kilometers. In the air-to-air arena, the aircraft can carry a combination of 3 beyond visual range missiles and 2 short-range missiles internally, providing a fire-and-forget capability against maneuverable aerial targets. Notably, despite initial claims of an internal cannon, recent design iterations suggest the Su-75 may lack an internal gun, a weight-saving decision that forces pilots to rely on external gun pods if a cannon is required, a compromise that mirrors the design choice of some F-35 variants, but risks leaving the aircraft defenseless in emerge if the pod is not mounted. The maximum combat payload is stated to be around 7.4 tons, a figure that includes both internal and external stores carried on wing pylons for non-stealth missions, further highlighting the aircraft's role as a bomb truck for permissive environments once air superiority has been established. Construction of the Su-75 takes place at the Yuri Gagarin Aviation Plant in Komsomolsk-on-Amur, a facility that is currently straining under the dual pressure of wartime production demands and the technological embargoes imposed by Western nations. The assembly process leverages existing tooling and infrastructure originally developed for the Su-57 program, allowing for cost savings and faster iteration, though this dependency also means that any delays in Su-57 production cascade down to the Checkmate timeline. The airframe relies heavily on composite materials which make up a significant percentage of the structural weight to reduce radar reflectivity and improve the strength-to-weight ratio. But the production of high-quality carbon fiber composites is complicated by the loss of access to advanced autoclaves and precursor materials from Europe and Japan. The sawtooth design of the landing gear doors and access panels, critical for scattering radar waves, requires manufacturing tolerances measured in fractions of a millimeter, and any deviation due to inferior tooling or rushed production could result in gaps that act as radar reflectors, effectively nullifying the stealth advantage. To mitigate these risks, Sukhoi has employed digital twin technology and supercomputer simulations to optimize the aerodynamic shape and streamline the assembly process, theoretically reducing the time required to build prototypes. The modular design philosophy allows for what engineers describe as radical changes in the functionality of the entire aircraft complex while keeping transport capabilities unchanged, with the concept of replacing the fuselage head section to create different mission variants from a single base platform. The timeline of this program reads like a case study in the gap between ambition and execution. Originally, the first flight was scheduled for 2023, then pushed to 2024, and subsequently delayed again to 2025. As of the most recent announcements at the Dubai Air Show 2025, Russian officials have stated that the first prototype is almost at the stage of flight testing, with bench and rig tests currently underway. The head of the flight department at Sukhoi has indicated that the maiden flight should occur in early 2026, with the aircraft currently in the workshop undergoing final assembly. These delays stem from a perfect storm of challenges, including international sanctions, supply chain disruptions, and the redirection of national resources towards supporting frontline operations in Ukraine. Industry executives have acknowledged that developing a clean sheet fighter typically requires 10 to 15 years of sustained effort, and the Su-75 program only recently entered the earnest development phase after years of preliminary work. Looking toward the future of air combat, the Su-75 is being developed with multiple variants in mind, reflecting the evolving nature of modern warfare. The Dubai Air Show 2025 revealed scale models of not just the baseline single-seat fighter, but also a two-seat trainer variant and a fully unmanned version that has generated significant interest among potential buyers. The twin-seat configuration opens opportunities for training missions and complex strike operations, where a dedicated weapons officer could manage targeting systems while the pilot focuses on flying, aligning with regional procurement trends where dual-seat variants of aircraft like the F-15 and Su-30 remain popular. The unmanned variant, sometimes called the light tactical aircraft in its autonomous form, represents perhaps the most strategically important development, positioning Russia to compete in the growing loyal wingman market. This cockpitless version would trade the weight of the pilot and life support systems for increased fuel capacity or payload, theoretically allowing for high G maneuvers that would be physiologically impossible for a human. The concept envisions networked swarm formations where unmanned checkmates could operate alongside manned Su-57's, extending sensor reach, conducting reconnaissance in high-threat areas, and carrying weapons into contested airspace where risking a human pilot would be unacceptable. Russia's experience with loyal wingman systems, including the larger S-70 Okhotnik B heavy drone, provides a foundation for this capability. Though a 2024 incident in which a Su-57 had to shoot down a malfunctioning Okhotnik B during operations over Ukraine illustrates the significant technical challenges that remain in autonomous control, data link stability, and target identification. The economic logic of the program is predicated on capturing a market segment that has been largely ignored by Western manufacturers. The estimated unit cost of approximately $30 million is aggressively marketed to potential clients in the Global South, including India, Vietnam, Argentina, Iran, and the United Arab Emirates, as well as numerous African and Latin American nations, as a cost-effective alternative to the $80 million F-35 or the political baggage associated with Chinese hardware. Russia has estimated the global demand at around 300 aircraft over the next 15 years, with particular focus on nations seeking fifth-generation capability without the associated costs of American or European options. The offer to India reportedly includes exclusive rights for indigenous production, a proposition that could potentially sideline Western defense contractors competing in India's multi-role combat aircraft competition. Some analysts suggest India should seriously consider the Su-75 as a cheaper alternative to fighters like the Gripen or Rafale, though New Delhi remains cautious given past difficulties with collaborative projects like the abandoned fifth-generation fighter aircraft program based on the Su-57. However, this price point likely excludes the cost of the engines, weapons, and support infrastructure, and is heavily dependent on securing a large-scale anchor order to amortize the immense research and development costs, an order that has yet to materialize as potential buyers remain wary of sanctions and the uncertain reliability of Russian supply chains in the current geopolitical climate. The question of whether the Su-75 can truly compete with the F-35 comes down to more than just specifications on paper. The American aircraft benefits from a massive industrial ecosystem, established training pipelines, interoperability with allied forces, and proven combat systems that have been refined through years of operational experience. Russia, despite its engineering heritage, faces the challenge of building not just an aircraft, but an entire support network from scratch while operating under crushing economic sanctions. The loss of access to Western semiconductors, precision machining equipment, and composite materials has fundamentally altered the trajectory of Russian aerospace development. Critics argue that the Su-75 is more likely a paper tiger than a genuine weapon of war, a high-tech concept that Russia simply cannot afford to build at scale. Supporters counter that if Sukhoi delivers even 80% of what has been promised, the Checkmate could disrupt the global balance in air combat for decades to come by democratizing access to stealth technology. Ultimately, the Su-75 Checkmate stands as a stark symbol of the Russian aerospace industry's resilience and its vulnerability. A machine that looks impressive on paper with its Mach 1.8 to Mach 2 speed, nearly 3,000-kilometer range, and advanced artificial intelligence logistics, but which in reality faces a treacherous path through industrial bottlenecks, technological embargoes, and the unforgiving economics of modern defense procurement. The next 12 to 18 months will be decisive as the world watches to see whether the first prototype actually takes off and begins the long process of flight envelope expansion and systems integration. If the maiden flight occurs as now projected in early 2026, it would validate years of effort and potentially unlock export interest that has remained tentative. If not, the program risks becoming another in a long line of impressive mock-ups wheeled between international air shows, generating headlines but never leaving the ground. For now, the Su-75 is edging its way out of the PowerPoint phase and into genuine hardware testing, with Russian officials clearly hoping to signal momentum on the global stage. But until a prototype actually takes flight, the Checkmate will continue to be judged less by its promises and more by its ability to meet the most fundamental milestone of any aircraft program, leaving it starting square on the chessboard and proving it can fly.